Hello, everyone. My name is Kiran Lokhande. I'm a data consultant with Greenleaf Consulting Group with over 12 plus years of experience in building enterprise data platforms. I've just passed my Databricks certification and I am starting a 5-part mini series on called Databricks in Practice. It's all live code. There are no slides, no fluff, just the patterns that is going to work, that actually work in production. So let's get started. If you've been working with Databricks for a while, you've probably used Delta Lake. You know you can create a table, you write some data, you run some queries on it. But most engineers stop there. They miss the features that Delta Lake offers. And we're going to talk about 3 such features. In this video, I'm going to show you 3 things. One, we're going to talk about time travel. And then how do you optimize your Delta tables for query performance, for real query performance? And then third thing, we're going to talk about how do you manage data retention properly using vacuum command. So let's get started and let's jump right into time travel. Um, Time travel, right? This is like one of the most important features that Delta table has to offer. It sounds like, oh, what is time travel? It sounds like a gimmick, but it actually works. And it's you will need it when you are working on production pipelines. So let's start this. Okay, first let's create a simple table. I am going to create, set it to Python. I'm going to create a simple table. Yeah, let's do, this is a simple, this is a data frame with employees. And then I'm going to create a data frame of it. Oops. So, create data frame. Yeah. So we have this data frame. ID, name, and salary. And now I'm going to write this data frame into a table. I'm going to create a table out of it. So df.write.format. I'm going to create a delta table. So let's do delta. If you already have it, if you already have this table, you're going to set the mode to override. Okay, and then I'm going to save this as a table. Save as table, and then I'm going to save this into, I already have a catalog and schema. I'm going to just reuse that. Demo.employees. Okay. So created data here, then created a data frame out of it. Oops. Then, yeah, let's run this. Perfect. So let's look into our catalog, mini series, and then demo. Yeah. Okay, now let's run this table. Let's see what do we have in this table. Mini series.demo, and then employees. Okay, perfect. So now we have a simple employees table. To show you the time travel feature, we're going to make a couple of updates to this table. So let's do that. So first from Delta, yeah, we need to import Delta tables and then import start. Let's get on. And now I want to data frame, Delta table. I hate this sometimes. And then here I want mini series dot demo dot employees. Okay. Okay, perfect. And now I'm going to make these updates. So dt dot update, and I'm going to make updates based on the ID column, right? So when I have ID is equal to 1, ID is equal to 1, I'm going to change the salary. Salary of it. I want to change that to say 1200, right? So this is my first update. And then in my second update, yeah, let's change that to 2200. Now let's run this. I might get perfect. Okay, so we have these updates. Now, this is where it gets interesting, right? Every write operation or every update operation in Delta Lake, it creates a new version of that table. So I'll show you what I'm talking about. Now I'm going to do describe. Let's do SQL describe history on that table, right? So I'm going to copy this table here. So we're going to describe history on this table. We'll see what all updates happen on this table, right? That's needed for time travel. So I'm going to run this query. Yes, perfect. So these are the different updates that we performed on this table. You'll see these two updates on ID1 and ID2. So these are the different versions that are available for you to time travel to. Now, for example, Delta is like always tracking every single change. So now if someone says that, okay, what happened? Like I want to go to the table as of yesterday, you could easily use the time travel command. So let's do that. I'll show you how to use that. So let's select this to SQL, select star from this table, and then I'm going to do version as of. Say if I want to see what how that table look after the first update was performed. So all I will do is you just use version as of 1. And if you see, you'll just see the first update, so 1200. You won't see the second update of 2200. Now, if you want to see the second update, I think it is say version as of 3. If I do version as of 3, you're going to see both the updates, 1200 and 2200. So that's it. You get point in time snapshots of your data with zero infrastructure. All you have to do is use the version as of. You could also use the timestamp as of command for it. So for example, here, timestamp as of, instead of version as of, you could just use the timestamp available here. So if I want to see timestamp as of this one, 3, you will see both the updates available, 1200 and 2200. So this is huge, like time travel comes in handy when you're debugging bad pipelines or auditing, or you're just recovering from an accidental override. So time travel is a very important functionality that is available with Delta tables. All right, in section 2, we're going to talk about optimize plus the order. This one directly impacts your query performance. So if your Delta table is getting slow and you want to optimize it, this is optimize command is the first thing that you should reach for. So here's the problem it solves. So over the time, whenever you make changes to a Delta table, right? or if a pipeline keeps writing small batches of data to your delta table ends up with hundreds and thousands of tiny files. What Spark does, it every time an update is done, it creates a small file with the new updates. So that's what we call it. We call this problem as a small file problem. And then I have a table. I'm going to show you a table that I already have. Describe history, sorry, describe detail. Let's convert this into SQL first. Describe detail. In my mini series, instead of employees, I already have a table called NYC taxi. So let's look at this table. First, I'll show you a simple table like the employees table and how many files does it have. So employees. Here, if you see, the number of files in this table is only one, right? I did not make a lot of updates, so that's one. And now in NYC taxi, this is a larger table. It's not very big. It's bigger than employees table, and I had made multiple updates to it. So you'll see the number of files here are 3. So we want to optimize this table. So I'm just going to run an optimize command on this one. So let's do optimize. Optimize. We're going to run change employees. Yeah. So we're going to optimize the NYC table. So you'll see after the optimize command, the number of files will be dropped down because, let's run this command first. And now I'm going to show you describe detail. And then this is going to be nice. Okay, so now you'll see after NYC taxi, sorry. So after running the optimize command, you'll see the number of files, it has dropped down to 1. So what optimize command does is it compacts all those small files into a larger and more efficient ones. So this is how the optimize command works. We can go further by using Z order. So let's change this to optimize. First, let's do C. Optimize mini series demo nyc taxi. So we can now we're going to use Z order for this, right? So optimize, let's see, order by, and then say for example I want to Z order by one of the columns is pickup zip, so I want to Z order by that one. So what Z order does is it co-locates related data of the field that you've chosen, and it will create files based on the column you have specified. So if you're analyst or if you have queries which are constantly filtering using the same ID or the same column, say for example in this case pickup zip, you will tell Delta to physically organize the data around this column. So now when a query comes in filtering on pickup zip, what Delta does is it skips the files that are not related to the zip that you've given, which is relevant, So that's called data skipping. And on large tables, it can cut your query time dramatically. So one thing to note, Z order is most impactful, or it's impactful on larger tables, like hundreds and thousands of gigabytes. On small tables, you won't see much of a difference, but it's always good habit, to build that into your pipeline maintenance. So this is how This is how optimize and Z ordering works. So in the last section, we're going to talk about vacuum. This is one people skip most of the time and then wonder why like their storage bill is so high. So time travel works by keeping old versions of files, and that is good for recovery. But those old files do not, disappear automatically. Vacuum gets rid of them, or vacuum command cleans them up. So let's write a vacuum command on our employees table. So let's convert this into a SQL first, vacuum, and then mini series demo.employees. Okay. And then I'm going to run a vacuum command on it. By default, vacuum deletes files that are, older than 7 days. And then, so 7 days window is your time travel retention period. If you want to travel back beyond that 7 days, it is not going to work because you got rid of all the files that are older than 7 days. So by default, 7 days is your retention period. You could also change the retention period by using, this command. Oh, so I'm going to do vacuum series demo.employees. And then we're going to change that. So retain as of 168 hours, Sorry. I think it's just retain. And then there's a space here. Hours. We're going to do hours. Yeah. I have done this in the past. I've seen many engineers do it and regret it like almost right away, changing the retention period to 0 hours. So what it does is when you set the retention period to 0 hours, all your historical versions are gone. You do not have then the time travel feature available to you. It's gone. So you cannot recover from this. So be very careful when you use retain 0 hours, because if you use that, your time travel functionality, you won't be able to use it. You could do this if you have like, a storage constraint, or you know exactly what you're deleting. I would not do this on production. So in production, the right pattern is to run a vacuum on schedule. So a weekly vacuum on the tables are fine. You have that 7-day retention period, and you leave that the default retention period as 7 days, unless you have some compliance requirements or anything. So yeah, that's all for vacuum. So in this mini series, we spoke about 3 features that separate engineers who use Delta Lake from engineers who use Delta Lake well. So we spoke about time travel. We spoke about optimizing your query, and we also saw how to use the vacuum command, how to keep your storage clean without getting rid of all the history. In the next video in this series, I'm going to do a live code on a full medallion architecture. We're going to talk about bronze layer, silver layer, and gold from scratch, and we'll use autoloader. If you don't want to miss it, please follow our page, Greenleaf Consulting Group. And if you have any questions, drop a comment and we'll try our best to get to it.